An organic chemistry is a study of structure and properties, composition, reaction, and the preparation of carbon-containing compounds. The only atoms specified the written are oxygen, chlorine, nitrogen, etc. These compounds are also called aliphatic compounds. Consists of a straight or branched chain of the compound. Hello students, I am Ramya, lecturer in chemistry from Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to discuss about organic chemistry, some basic principles and techniques. In this particular session, we are going to discuss introduction, tetravalency of carbon, shapes of organic compounds, hybridization and bond characteristics, structural representation of organic compounds, classification of organic compounds, homologous series, nomenclature of organic compounds. Introduction. An organic chemistry is a study of the structure and properties, composition, reaction, and the preparation of carbon-containing compounds. Most of organic compounds contains carbon and hydrogen, but they may also include a number of other elements. Organic chemistry can be defined as a branch of a chemistry which deals with the study of hydrocarbons and their derivatives. History. In ancient times, it was believed that a vital force is necessary for the production of an organic compound. But in 1828, Friedrich Müller prepared a urea in the laboratory by heating ammonium thiocyanate. It was first organic compound prepared in the laboratory. Ammonium cyanide, heat to give urea. Then another ancient scientist, that is coal-base, synthesized the acetic acid, and Burhat synthesized methane in the laboratory. Nowadays, about 95% of the organic compounds synthesized in the laboratory. Tetravalency and catenation property of carbon. So, why we need to study carbon separately? It has a unique property, that is catenation and tetravalency. Carbon is a unique element and form a large number of compounds due to the property call it as catenation and tetravalency. Due to the following reason, we have a unique property in carbon. Tetravalency of carbon. In all of its compounds, the valency of carbon is 4. The carbon has tetravalency, that is 4 electron in its valence shell. It requires 4 more electrons to complete their octet. So, it attains octet configuration by forming 4 covalent bond. Covalent bond means the mutual sharing of electron to form a bond. We call it as covalent bond. Ability to form single bond and multiple bonds. Carbon having an ability to form single and multiple bonds due to the with itself or also with the other elements like oxygen, nitrogen, etc. This is possible in sp3, sp2 and sp hybridization. Catenation. Carbon shows catenation. It's a self-linking property of an element to form long chain or a rings. Isomerism. Carbon compound shows isomeric property, that is the compounds having same molecular formula but different in the structural formula. This phenomenon is called isomerism. Shapes of carbon compounds. Hybridization influence the bond length and bond enthalpy in the organic compound. So, if the hybridization is sp3 hybridized, the shape will be tetrahedral. If it is sp2 hybridized compound, the shape of the compound will be trigonal planar. If the shape of the hybridization is sp, the shape of the compound is linear. Characteristic feature of the pi bond: sideways overlapping. The axes remain parallel and perpendicular to the internuclear axis. Free rotation about the bond is restricted. Electron chain cloud of the pi bond is located above or below the plane. They provide most reactive center in a molecule contains multiple bonds. Structural representation of organic compound. Complete the structural formula, condensed structural formula, bond line structural formula, 3D representation. Complete structural formula. Here all the bonds between the atoms denoted by dash. A single dash represents single bond, a double dash represents a double bond, and a triple dash represents a presence of triple bond. So this is ethane. So ethane is a single bonded compound and this is ethene. It is double bonded compound. This is ethyne. This is triple bonded compound. Condensed structural formula. Here the carbon and hydrogen bonds are all the bonds are omitted except the multiple bonds. It is a simplified representation of organic compound. The condensed formula can again simplified as follows. Butane. So here 4 carbon atoms are present. So we call it as butane. 1, 2, 3, 4. So the second and carbon atom represented in this way. This is hexane. The successive series of CH2 group can be represented as like this. It can be called as condensed formula. This is decane. The primary and terminal carbon is represented. The middle carbon can be represented as like this. This is called as decane. Bond line structural representation. It is the simplest form of representation of organic compounds. Here the carbon and hydrogen are not shown in the structure and lines representing the carbon are drawn in a zigzag fashion. The only atoms specified the written are oxygen, chlorine, nitrogen, etc. The free terminals can be considered as presence of methyl group. If it is propane, we can write the structure of bond line structure of propane like this. So this terminal, both the terminal contain CH3 group, that is methyl group. This edge represent the presence of CH2 group. This is butane, presence of 4 carbon. This is propane. Propanone, presence of 2 methyl group and 1 ketonic group, that is C double bond O group. This is cyclopropane, presence of 3 carbon in a ring structure. We call it as cyclopropane. 3D representation. Here the structure of an organic molecule can be represented by the solid dash wedges. The solid dash wedges to indicate the projecting the out of the plane of the paper are towards the observer. The dashed wedge indicate the bond projecting out of the plane paper and away from the observer. The broad end of the wedge is always towards the observer. The bond lying on the plane of the paper is dissipated using a single normal line. So this is the representation of 3D representation of methane. This dash wedge represent the bond away from the observer. The solid wedge represent bond towards the observer. Simple line represent bond in a plane of a paper. Organic compound can be classified into Acyclic or open chain compound are aliphatic compounds. These compounds are also called aliphatic compounds, consists of a straight or branched chain of the compound. So this is propane having straight chain. This is isopentane having branched chain. This is isobutylamine. This is branched chain. This is propane. This is straight chain. And this is propine. This is straight chain. Cyclic or closed or ring compounds. Compounds in which carbon atoms links to each other in atoms in elements in closed chain structure or a ring structure. Homocyclic or carbocyclic compounds. Compounds which contain ring made up of the carbon atom only. The homocyclic compounds are classified into alicyclic compound or aliphatic cyclic compound. Compounds which contains a ring of 3 or more carbon are connected by a single or double bonded and resemble aliphatic compounds in their properties. So this is cyclopropane, cyclobutane, cyclopentane and cyclohexane. These are all the cyclic compounds represent the aliphatic property. Aromatic compound. The compound contains at least one benzene ring. Aromatic compound are classified into two types, that is benzenoid compound. Aromatic compound consists of at least one or more benzene ring or a fused isolated benzene ring are called benzenoids. This is benzene. Benzene with methyl group, call it as toluene. Two benzene attached together, we call it as naphthalene, and 3 benzene attached together, what we call it as anthracene. Benzene with hydroxyl group, that is alcoholic group, we call it as phenol. Non-benzenoid compounds. Aromatic compounds without a benzene ring are non-benzenoid compounds. Tropolone, tropone, azolene compounds. Heterocyclic aromatic compounds. These are the compounds containing ring structure in which one or more carbon atoms replaced by heteroatoms such as nitrogen, oxygen, etc. This is furan, this is triophen. Functional groups. Atom or a group of atoms joined in a specific manner which is responsible for the characteristic chemical properties of the organic compound are functional groups. We have number of functional group. So that is, if carbon containing double bond, we call it as alkene. General formula CnH2n. If carbon containing carbon-carbon triple bond, we call it as alkynes, represented CnH2n minus 2. If OH group is present in an organic compound, we call it as alcohol and represented by ROH. Here R, it may be alkyl group or aryl group. If NH2, call it as amines, represented as RNH2. CHO, we call it as aldehyde, represented as RCHO. C double bond O represent the ketone, we call it as RCOR. Carboxylic acid, that is COOH, RCOOH, general formula. Ester, COOR, that is RCOOR, general formula. Amide, CONH2, RCONH2, we call it as general formula. COCl, acid chloride, RCOCl is a general formula. Cn, nitrile, RC double bond N, we call it as nitrile. NO2, that is nitro group or NO2. OR dash, that is ether, ROR dash. X represent halogen compounds. X may be represented as chloride, bromide or iodide. General formula RX. Homologous series, a group of series of a compound each containing characteristic functional group forms a homologous series. The successive member of differ from each other in a molecular formula by CH2 group. For example, for homologous series of alkanes, alkenes, alkynes, alcohols, ethers, carboxylic acid, aldehydes, ketones, amines, halo compounds, methane, this is CH4, ethane, C2H6, propane, CH3, C3H8, butane, C4H10, pentane, C5H12, hexane, C6H14, heptane, C7H16, octane, C8H18, nonane, C9H20, decane, C10H22. Nomenclature of organic compounds. An organic compound has two names, the common name and IUPAC name. The common name is based on the source or the properties. For example, citric acid is named because it's found in citrus fruit, and the acid found in red ants is formed as formic acid, since the Latin word ant is formica. The compound methane, this is some of the compound and their common names. IUPAC system, a systematic name of an organic compound, is generally derived by identifying the parent hydrocarbon and the functional groups attached to it. This name we call it as IUPAC name. It contains three parts, that is root word, suffix and prefix. The root word indicates the number of carbon atom in the compound. This is the root word. The longest chain of carbon in the given organic compound, we call it as root word or the parent chain, and the other substituent attached to the root word, we call it as one is branched chain and other two are the functional group. Here we have two functional group, one is OH and another one is Br. Prefix indicate the substituents. Root word indicates the number of carbon present in the longest chain. The primary suffix indicates the saturation or unsaturation for alkane. The primary suffix is alkane, alkene and for alkyne. The secondary suffix indicates the functional group. Root word, the root word of the compound containing 1 to 10 carbon atoms are as follows. If we have only one carbon, we can call it as root word meth. If 2 carbon, eth. If 3 carbon, prop. If 4 carbon, but. If 5 carbon, pent. If 6 carbon, hex. If 7 carbon, hept. If 8 carbon, oct. If 9 carbon, non. If 10 carbon, dec. Prefix, alkyl group notation are, that is alkyl, nitro, NO2, nitro, that is halide, X, halo, fluoro, chloro, bromo or iodo. Suffix, the class of the compound alkane, that is ANE, alkene, ENE, alkyne, YNE, alcohol, OAl, aldehyde, AL, ketone, ONE, carboxylic acid, oic acid, amines, amine. In the next session, we are going to discuss about IUPAC name or a nomenclature of a alkane in straight chain, hydrocarbons, rules for naming branched alkanes, naming of cyclic compounds. Thank you.